Good morning. This is a lecture on the basic rules of algebra, lecture 1.4. Again, terminology, variables, algebraic expressions, substitution, and evaluating an expression. Okay, we did those already. Okay, evaluate the expression given when x is equal to 14. Okay, so this is what we have to plug in because we're evaluating. Evaluate means to give me a number answer, just a number, not an x equal, not a b equals, just a number, 10, whatever. Okay, so we plug in 14 for x. So we have 2 times 14 plus 13.25. 2 times 14 is 28. Okay, 28 plus 13 is going to be 28, 38, plus another 3 is 41.25. Evaluate the expression given x is 3 and y is 8. 8 times 8 plus 1 plus 10 times 3. So we have 64 plus 1 plus 30. That's 94 plus 1, so 95. All right, evaluate this expression, 7 times x plus 3, when x is 2. We're going to have to use our order of operations because we have to make sure that we we do the parentheses first. I apologize. That I should need to plug in what my x is. Okay, so x is 2. Well, 2 plus 3 is 5. 7 times 5 is 35. All right, now we're plugging in an x of 6. So we have 7 times 6 plus 3 times 6 minus 2. What does that equal? Well, 7 times 6 is 42. You got to know your times tables. Plus 3 times 6 minus 2 is 4. So now I have 42 plus 12. Well, 42, 52, 3, 4, 54. All right, now we're plugging 7 in for x. So we have 3 times 7 minus 5 plus 2 times 7. So that's 3 times 7 minus 5 is 2. 2 times 7 is 14. All right, 3 times 2 is 6 plus 14. And now I have 20. There we go. All right. Okay, more terminology. This is now the terminology of expressions. So, for an expression, a term is the parts of the algebraic expression that are added or subtracted. So like in this case, 3x, 4, and negative 5y. A variable term would be one that contains a variable. So in this example, 3x and the negative 5y are both variable terms. Coefficients are the parts of the variable terms that are numbers. So the coefficient of the 3x is 3. A constant term, or just you can call it just the constant, a constant has no variable, it's just a number. So in this case it was the 4. All right. Now, properties of real numbers. We have commutative property. Now, the commutative property, when your parents drive to work, we call it commuting. They have a short commute, they have a long commute. It's a commute. And what they're doing is moving from one place to another. So the commutative property is just about moving things from one place to another. So let's look at this. So the commutative property for addition, we see that the A moved to the end. And the B, okay, so, and the B, there we are. Now, changing the order when adding does not affect the sum. Okay, so notice it's for addition. Mind you, it is not for multiplication. It's not for subtraction. You have to keep the negative. So if you want to commute something around with a subtraction, you have to turn it to a plus a negative, and then you can move the whole negative number around. All right, commutative property for multiplication. Again, it flips them around. Notice again the A shifts to the back, and the B shifts to the front. All right, using the commutative property. So this is just, we don't have to solve anything. We don't have to evaluate anything. We're just going to commute 7 plus x. X times 7. This we can do both. So we're going to flip the 3 and the y, and we're moving the 5 to the back. So we did two. We did both the addition and the multiplication. Okay, now we have the associative property. Well, the associative property, in the United States, we have one of our Bill of Rights is the right of association, which means you can associate with whoever you want to. If you want to hang out with a bunch of skinheads, you can do that. If you want to hang out with a bunch of Democrats, you can do that. You can hang out with whomever you please. That's your given right according to the Constitution of the United States. So the property of the associative property is all about who you can associate with. So for addition, you can associate them however you wish. You can put the there we go. Okay, we can put the A plus B together. We can associate them, or we can associate the B and C. Perfectly fine, doesn't matter. Same holds true for multiplication. AB can be associated, or BC can be associated. Totally fine. They can associate with whomever they wish. So, to use the associative property, what we're going to do is we're merely going to change the parentheses. So now we have 3 plus 9 plus y. We have x plus 13 plus 4. Okay, we also have 3 times 4x, and we would have 12 times 2x. So we can associate however we like. Now the distributive property states that I can take multiplication and distribute that multiplication across pluses or subtractions, additions or subtractions. So you can see in the example here, the A gets distributed to both the B and the C. So the A goes to the B, and I don't know if you can even see that. Make it dark. B and to the C. And we have that. So that's going to make a difference. So I can get rid of parentheses that way. Okay, simplify using the distributive property. So this becomes 4x plus 20. Sorry, I rotated it again. This becomes 3y plus 12, which is 3 times 4. This one becomes 8y, that takes the 2 times the 4y, plus 2 times 5 is 10. Okay, that's our distributive property. Very powerful. All right, other forms of distributive property. Notice that I'm going to do it the highlighter, and the red doesn't show very well. Okay, I mean the yellow. All right, so the A, I can distribute it to both the B and the C. Right, it's right here and here. Oof, that's a little too dark. Let's shift a little bit lighter. A can shift, but now it can actually go to all 3 of them. Notice it now sits at all 3. It can distribute backwards if you want to, so that A is now on the B and the C. Either one works. It has to do with that whole commutative property. All right, simplify the following. All right, so we have, I'm going to multiply that in, 3x minus 3 times 4 is 12. 5 times 2 is 10. There is no coefficient. That's the constant part of a term on the x, so it just becomes 5. Basically, the unwritten net coefficient is 1. All right, so now I have 4x plus 4y plus 12. All right, and for my number 4, I can go backwards. 2 times 6 is 12, and 2 times x is 2x. Okay, a couple more slides. Hang in there. Okay, combining like terms. Terms that have the exact same variable with the exact same exponent. Examples of like terms. 4x and 3x, or 2x squared and, that should be a comma, 5x squared. Notice they both have the x squared. Non-like terms, 4x and 5x squared. Not alike because one has x squared and one has x. So on this, which of the following are like terms? All right, so we're going to do some highlighting here. All right, so all my constants would be like terms. 5 and the 25 and the 1/2. You can add those all together. All right, all my single x's, so 2x, x, and 1.3x. Now, there is only one x squared, so it's all by itself. It doesn't have any like terms. All right, so steps to combining like terms. Add or subtract the coefficient of the terms. Use the results of step 1 as the coefficient of the terms variables. All right, so what does that mean? Well, I look at this and I have 3x and 2x. So I'm going to add those two together first. 3 and 2 is 5, so that gives me 5x. And I only have the constant left. So I've simplified it. I've combined like terms. All right, I can put the 7 and the minus 2y. Basically, I'm associating them. And I get 7 minus 2 is 5. And then I'm going to associate the constants. 4 plus 2 is 6. I cannot combine those because, of course, they aren't like terms. All right, number 3, I have A's and I have B's. So I have to add the A's together, and then I'm going to add the B's together. All right, again, 7's 7 minus 2 is 5. And the b's are all by themselves. And then I have the constant 6. There we go. All right. Simplifying algebraic expressions. I know this is a big lesson, so hang in there. You can do this. All right. Simplifying algebraic expressions is simplified when the parentheses are removed and all like terms have been combined. So, first thing we're going to do is use our distributive property to get rid of our parentheses, since we can't solve what's inside the parentheses because they have a variable. All right, so I'm going to end up with 14 plus, now I have 2x plus 6. Now I combine the 6 and the 14, I get 20 plus 2x. That would be my simplified expression. I do the same thing on number 2. So I have 12 plus 15x plus 10 plus 5. Well, now I have 3 constants. I'm going to add 12 to 10 and 5. So 12 and 10 is 22, and 5 is 27. So I have 27 plus the 15x, which is all by itself. All right, here I've got 8x plus 20 plus 12x. I'm going to add the two x's together. I have 20x plus 20. Yay! All right. Why would you distribute instead of adding? I already mentioned at the beginning, it's because you don't have like terms inside of the parentheses. If you had like terms in the parentheses, you do that first because it's easier, and then multiply. All right, last slide. Simplify. Okay, 14b minus 5b, they're like terms. I get 9b. 7 plus x plus 10. Well, there's no coefficient, nothing multiplying, so there's nothing to distribute. So I can just get rid of those parentheses. 7 and 10 is 17. And then I still have my x all by itself. All right, here I'm going to add the x's together. 7 and 2 is 9. And then I add the two constants. 8 minus 3 is 5. All right, I distribute. I have 10x plus 10 minus 4. So that's going to be 10x plus 6. 10 minus 4 is 6. All right, our next one is going to be 14 plus 2 times 5x is 10x. 2 times negative 1 is a negative 2, so I have minus 2. I'm going to combine my two constants. I have 12 plus 10x. All right, one more. Distribute the 6 in. That's going to give me 30x minus 30 minus 4x. All right, 30 minus 4x, putting those two together, I have 26x minus 30. Oh, that's a terrible 30. My zeros way too often look like 6s. There we go. All right, and we are done. Have a good day, work on your homework, and we'll see you tomorrow.